water, earth, fire, air. Many years ago, it was believed that these four elements were the origin of everything and the basis of matter. But everything changed when science proved this to be false. Indeed, thanks to the alchemists, whose obsession was eternal life and transforming everything into gold, the true elements were discovered. By the way, how proud the alchemists would be to know that we can now transform lead into gold. It only takes a particle accelerator. However, it's not as profitable as they thought. Transforming one element into another is more challenging than finding it in nature. But what are the elements? And why do we use the periodic table? Elementary particles come together to form protons, neutrons, and electrons, which in turn combine to create atoms. In total, we know 118 different types of atoms, which we call elements. The difference between them is the number of protons in the nucleus. An atom with one proton is an atom of the element hydrogen, and an atom with 118 protons is an atom of the element oganesson. Therefore, each element has a name and characteristics based on its number of protons. Atoms of the same or different elements can combine in various ways, giving rise to all the matter we know. The combination of two hydrogen atoms and one oxygen atom forms a water molecule. The way atoms combine also influences the properties of substances. For example, both graphite and diamond are made up of carbon atoms only, but they are arranged differently. Out of the 118 elements, 93 are found in nature. Everything, from the sun to your cell phone, is composed of combinations of these 93 elements. It's like having only 93 different types of Lego pieces with which you can build the entire universe. And don't think that the quantity of each type of piece is more or less equal. In the universe, 73% of atoms are hydrogen, 25% are helium, and the remaining 2% are all the other elements combined. Our own bodies consist of atoms from different elements arranged in various ways, giving rise to all our cells, tissues, and organs. It doesn't even require a wide variety of different elements. About 99% of our body is composed of atoms of carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus, along with a few more elements in tiny amounts. With this, we have a human being. To understand these elements, they have been arranged in an orderly fashion, one by one, in one of the most beautiful inventions, the periodic table. In the mid-1800s, around 56 elements were known, and more were being discovered over time. Many scientists tried to organize them, but the problem was that they didn't know how many elements were still undiscovered. It was like solving a puzzle with missing pieces, not knowing which pieces were missing and with some pieces that could fit in different ways. Alexander Baguier de Chancourtois discovered that if he arranged the elements by their atomic weight, their characteristics repeated, so he organized them in the form of a helix. However, chemists didn't pay much attention to Alexander's arrangement because he was a geologist, even though his idea was quite brilliant. Later, John Newlands also arranged the elements by their atomic weight, and he observed that properties repeated periodically. He suggested an analogy with the intervals in the musical scale. His table even predicted the existence of an unknown element, which was later discovered. Unfortunately, John also faced skepticism, but in reality, he wasn't far off the mark. There were other attempts until Dmitry Mendeleev came along. He studied the elements obsessively, even dreaming about them, and managed to arrange them perfectly. He organized the 66 known elements by their atomic weight and their ability to combine with specific other elements. Confident in his work, he asserted that there was an error in the atomic weight of uranium. He also predicted the existence of elements and their characteristics. Remarkably, he even stated that one element would be discovered using spectroscopy, and his predictions turned out to be accurate. Dmitry Mendeleev arranged the elements meticulously, yet he didn't know why elements in the same groups shared similar characteristics. At that time, the electron had not been discovered, and the understanding that the number of electrons in the outermost shell determines the properties of elements and their ability to bond with others was unknown. Since then, the periodic table has undergone some changes and refinements. Currently, it is ordered by the number of protons. Why is this invention so beautiful? Because it is the way we have been able to understand how matter works and interacts. It has such a perfect order and logic that it makes us sigh with relief, like when all the pieces of a puzzle fit together. It allows us to understand something that would otherwise be very complicated. It is true that there might be different ways to arrange it, but so far, it works well. It groups metals like gold, metalloids like polonium, and non-metals like carbon. The rows or periods indicate the number of energy levels or layers of the atoms. Those in the first row have one layer, those in the second row have two, and so on. The columns are the groups. The elements in the first group have one electron in their outermost layer. The elements in the second group have two electrons in their outermost layer. Omitting the transition metals, if we continue with this third column, each element has 3 electrons in its outermost layer, and so on until the last column, which has 8 electrons in its outermost layer and is superstable. All elements want to be as stable as these elements. The elements in each group share characteristics because they have the same number of electrons in their outermost layer. For example, all the elements in group 1, except for hydrogen, react violently with water, which is why they are not found in nature in their pure form. As you go down a group, the atoms will become larger because they have more layers. As you move to the right across a period, the atoms will become smaller because they have more protons in their nucleus, which will attract the electrons towards the center. Now, with what we have told you and without knowing anything about boron, just by looking at its position, you can see that it is a metalloid. It has 5 protons in its nucleus and 5 neutrons. Like all atoms, except hydrogen, it has 2 electrons in its first layer. From its group, you know it has 3 electrons in the second layer, and since it only has 3 electrons in its outermost layer, it is unstable, and it is most likely to be found bonded with other elements. The formation of elements is a fascinating process that occurred over billions of years in the history of the universe. After the Big Bang, the universe was extremely hot, dense, and radioactive, and individual atoms couldn't form at that time. However, it did create fundamental particles, and eventually, protons, neutrons, and electrons were formed. Around 380,000 years after the Big Bang, the universe had cooled down enough for the first atoms to form. Primarily, hydrogen and helium formed since these were the simplest and smallest elements that could remain bound together under the conditions at that time. There was also a small amount of lithium formed during this period, along with beryllium and boron, which are produced when cosmic rays collide with the nuclei of other atoms. From lithium to iron, elements are formed in the cores of stars through nuclear fusion reactions. This process involves the fusion of lighter elements to form heavier ones, releasing energy in the process. It's important to note that elements can be formed through various processes. For elements like gallium and bromine, a supernova explosion is required. The intense energy released during a supernova allows for the creation of heavier elements. The formation of elements beyond iron posed a mystery for a long time. Scientists knew that a rapid process involving an enormous number of neutrons was necessary. Recently, the formation of strontium was observed 140 million light-years away in a collision of neutron stars known as a kilonova. Elements with atomic numbers 94 to 118 have not been found naturally on Earth. They have only been created in particle accelerators and nuclear reactions, and they are highly unstable, decaying within fractions of a second. However, scientists continue to explore and study the possibilities of creating heavier elements. For example, a laboratory in Russia is working on discovering elements 119 and 120, but the success of their creation remains to be seen. If these elements are successfully created and confirmed, a new row on the periodic table could be added to accommodate them. This would be an exciting development in our understanding of the elements and their formation. And what properties could they have? Will we have to redesign the table? Some scientists think that finding new elements that last less than a second is not worth it, while others believe that maybe these elements exist in some remote place, or maybe they don't currently exist, but they did in the past. Understanding the universe is part of human curiosity and turns out to be an incredible story that makes us see how marvelous it is. Although Carl Sagan was not the first to say it, he was very eloquent in expressing it. All the rocky and metallic material we tread upon, the iron in our blood, the calcium in our teeth, the carbon in our genes, were produced 1 billion years ago inside a giant red star. We are made of stellar matter. If you liked the video, give it a thumbs up, share it, and subscribe to the channel. And don't forget to comment if you want us to talk about a specific topic.